So today we are going to talk about another networking concept in Azure, which is load balancer. Okay, so load balancer is one of the networking service I said. So it is a device, okay, which will help your application availability to be increased. Say for example, you have an application called facebook.com. When you host the application behind the load balancer with multiple application servers, your application availability will be high, means always the application will be up and running for you. Okay, if you consider 365 days, almost all the 365 days your application will be up and running with very minimal downtime. Okay, that is called as load balancer. The same definition I have written here. A load balancer means it's a device. With it your application will get load balance between virtual machines, between multiple virtual machines or instances, and they will increase your application availability. Means at any point in time, at any circumstances, your application will be up and running. How is that possible? When the users browse the application called www.facebook.com, your request will not go to the application servers directly. So the request will go to the load balancer IP address, and behind the load balancer there are multiple application servers of Facebook applications, the same applications, we have multiple servers. If one or the other application server goes down also, you have remaining application servers to fulfill your application. So load balancer has got a capability of identifying which is healthy, which is unhealthy, and it has got an topology to whom to send the request. If there are 500 application users are consuming the application, the load balancer will divide the load equally among the backend nodes. If there are 5 application servers and 500 users are accessing the application, it ensures 100 users per each application servers get distributed, and that is the work of the load balancer. So by using the load balancer, you can scale your application. Means your application will never go for performance issues. Okay, the application responds quickly, there is no downtime. Okay, and high availability. Even though if there are 5 application servers, even though one or two application server goes down also, the load balancer will divide the incoming application traffic to the remaining healthy application nodes. Out of 5, if 2 server get shut down also, you have still 3 servers are available to consume the load and respond back to the application user. Okay, and chances of losing your application is very negligible. I already told you during the introduction, at any point in time, Microsoft ensures your application will be available, because when you go with the load balancer, they will commit 6 digit of 9 SLA, means 99.9999% of the SLA. So there is no chances of losing your entire application for longer time. Okay. So now if we want to understand use of a load balancer, the load balancer is balances the incoming traffic. Okay, either the internet traffic or intranet traffic. Okay, it balances both the loads. Some applications are public facing, so you need internet to access the application. If you need internet to access the application, and if that load balancer is pointing towards the internet or facing towards the internet, we call that load balancer as public load balancer. So there are some applications within your office, maybe your leave portal, or maybe your HRMS, or your salary portal, or your personal information related portal at your office. That is, you cannot access via internet. You have to go to office network, and within the office network only you have to access. That is called as internal load balancer. If the traffic, if the load balancer, the traffic across virtual machines inside your office network or inside the virtual network of the cloud, that is called as internal load balancer. So only two things. If your application is public facing, we will use public load balancer, means internet facing. If your application is accessible within the office network, within the virtual network, That is called as internal load balancer. Okay, what scenarios will use internal load balancer? Maybe when you have multiple database and you wanted to ensure both the databases are acting like same, that time you will use internal load balancer. Or maybe you have an application within your office network and all the employees of the organization they use the application, that time you will use the internal load balancer. Okay, but the applications like public facing, maybe your Amazon, Flipkart, all these are public facing, anybody can access if they have internet, those they will go for public load balancer. Okay, and the port, the traffic, right, the port forward traffic to a specific port on the specific virtual machine means the load balancer will know the traffic coming from which port should go to which port. The traffic is specific. Okay, say for example a user is trying to access an application, the load balancer decides, okay, that user has to go to which node, it is node 1, node 3, node 2 or node 3, whatever it is, it decides. Okay, so you can see you can define the traffic from particular port should routed to the particular virtual machines. Say for example if you are using HTTP port number 80, then it will decide which server your traffic has to be forwarded. Some people they may use HTTPS 443 secured. Then your load balancer will decide to which server I have to forward the traffic, because the routing happens in the load balancer that depends on the port numbers. I'm going to show you that. Okay, and provide outbound connectivity for VMs inside your VNet by using the public load balancer. Means you have deployed the application servers in your office network, virtual network. You can even expose those application servers via public load balancer for the external users. The same thing happens. No, you have Facebook application server hosted in somewhere in AWS environment, somewhere we don't know, but you will deploy a public load balancer and add those 2-3 application servers called Amazon or Facebook or Flipkart behind that load balancer, and you, me, and everybody is trying to access Flipkart, Amazon, or Myntra, whatever public facing applications, to browse and get the things done. That is the uses of the load balancer. So you found it as interesting because the load balancer, it is an intelligent device, because it is identifying which traffic to be forwarded to which virtual machine behind the backend pool, right? So how that is possible? What kind of algorithm the load balancer uses? The Azure Load Balancer uses an algorithm called 5 tuple hash algorithm. Okay, means it consider 5 points actually. That is why we call it as 5 tuple hashing algorithm. Okay, that if you look at this description, load balancer uses 5 tuple hashing algorithm for distribution of the load inbound flows and writes the headers of the flows backend pool instance accordingly. Means what it will do, it will just list out the content, like what is the source IP. Imagine you are trying to access an application, it will take your application, your IP address, your computer IP address, and via which port you are trying to access. Are you using 192.168.1.10? What is the port number? It is 80 or HTTPS 443. And where do you want to connect? You want to connect it to the Facebook or Amazon or Myntra applications, correct? Na? So it will ensure what is the source IP address, what is the port number they are trying to connect, and what is the destination IP, what is the destination port, and what protocol I should use, whether it is a TCP protocol, UDP protocol, what kind of protocol it has to be used. So it will list out all that in a table format, and then it will decide which computer to be forwarded. Okay, so that is the 5 tuple hashing algorithm. If somebody asks you what is 5 tuple hashing algorithm, you can tell it is an algorithm used by the Azure Load Balancer to distribute the work loads or distribute the queries, application queries, to the backend nodes. Okay, so this public load balancer will have some other components of it. So it will have one front end IP. So when you try to access an application called facebook.com, www.facebook.com, it will have an IP address, and you don't hit the applications directly, you will hit the front end IP address of a load balancer. And that load balancer will also have backend pool. So each and every load balancer will have list of applications behind the load balancer. If I consider Facebook, if you see this here, let me take the no. See here, in this scenario, you are here. This is your computer, and you are trying to access. This is the load balancer. And if you see behind this load balancer, there are three computers are there. Application servers are there. Right now. So when you hit like www.facebook.com, you are not hitting the computer directly. You are hitting the load balancer, because load balancer will have its front end IP, FIP, front end IP. And behind this load balancer, you have backend pool. This is the pool. See, this is the backend pool. And in this backend pool, you will have number of virtual machines. And each and every virtual machines are identical. They are replica of each other. They have the same data, same applications, same content it has got. Okay, and you will write the load balancer rule stating that via which port number the application has to be accessed. What is the port number? What is the protocol? All these things. Then it has got another component called probes. While I giving the introduction, I told you load balancer identifies the healthy and unhealthy nodes behind the pool. It identifies, okay, out of 10 virtual machines, how many virtual machines are healthy in my load balancer backend pool. So that is possible with the help of the probe. Means probing is nothing but a kind of communication message which is going from the load balancer to the backend application node to check whether the health of the virtual machine is healthy or not. What is the status of the virtual machine? Is it healthy or unhealthy? So that is called as probing. So if you might have come across when you are driving during the night time, there will be a person will be always talking to the driver, okay, just to ensure the driver will not fall asleep, right? Just to keep him awake, we will be keep on talking to them just to ensure the driver is not sleeping, correct na? That is called as probing. So that is also possible. That component is also there in the load balancer. Okay, so now you know load balancer uses 5 tuple hashing algorithm, and that 5 tuple will have 5 components or 5 parameters. In fact, the source IP, source port, destination IP, destination port, and what protocol it has to be used. And the load balancer will also have some components of it. It will have the front end IP where you will hit the load balancer. When you hit the load balancer to access an application, the request will go to the front end IP of the load balancer only. And every load balancer have its own backend pool, and within the backend pool you have n number of application servers or multiple number of application servers with a similar configuration, same application, same content. Then load balancer will have a rule, because we will define what is the rule via how the application should be accessible. Okay, whether it is using port 443 or port 80 or any other application ports it has to use. All those things we will define. It will also have the health probe. Health probes are nothing but just to ensure the health of the backend nodes. We will create the probes so that the load balancer will keep on probing the backend nodes just to ensure whether they are healthy or not. If they find healthy, it will start distributing the load. If the load balancer finds unhealthy of any of the virtual machine, it will ignore from the distribution list. Okay, that's about the load balancer and the components. So there are two SKUs in the load balancer, whether it is a public load balancer or a private load balancer. Okay, so the first one is basic SKU, another one is standard SKU. So load balancer has got two SKUs. I told couple of things are defined here. Okay, if you look at this, the feature, The backend pool size, if you want to see, what is the difference between the standard queue and the basics queue? If I talk about the backend pool size, is it? So in the standards queue, you can add up to 1,000 number of virtual machines in the backend pool. Here I have only added 3 virtual machines. Correct, na? So if in case you have standard load balancer, you can go up to 1,000 number of virtual machines here. The same thing if you go to standard, maximum only 100 number of virtual machines can be added. The same thing I mentioned here. And backend pool endpoint. See, any VM in the single VNet or multiple availability set and VM scale set. So there is no limitations. Means you can have virtual machines from multiple VNets, multiple availability set and scale set can be added behind the standard load balancer. But in case of basic, you should always have the virtual machine from the same availability set or scale set or same VNet. If you create 2 virtual machines in 2 different VNet, 2 different region, if you have basics queue, you cannot add both under the same same load balancer, because the basics queue of load balancer will not support VMs from different availability set, VNet or the regions. In the standards queue, the probes will support all the 3 like TCP, HTTP and HTTPS. But in the basic, the secured connection is not possible. It does not exhibit any kind of security in terms of basics queue. See, you can only go TCP and HTTP but not HTTPS. HTTPS is nothing but hypertext transport protocol secured. Okay, HTTP. All your websites will have HTTP or HTTPS. If you type http://www.facebook.com, it will go to HTTPS means it will go to standard. HTTP, simply HTTP means it will only work in the basics queue. If you type https:// if you have standard basic load balancer, then the application will not be opened. It will not there you will not be able to open the application. Okay, and health probe down behavior. In the standards queue, if it is finding, say for example, there are 5 application servers, and out of 5, one application server is going down for 30 minutes. But after 31 minutes, if that becomes healthy, the standard load balancer will start distributing the load for all the 5 servers, because it will identify, yes, it was down for some time and after some time it is working, let me distribute the load. But in case of basic, once it is ignored stating there is the server 4 is having some issue, it will not reconsider when it becomes healthy also. It terminates probing that. Okay, that is the difference between that is the difference of health probe between basic and standards queue. Then availability zone. It is a zone redundant zone load balancer, means you can add virtual machines between 2 multiple regions and availability zones also, but the basic one will not support the availability zone. You should have the virtual machines within the same region and same data center in case of basic. And management operation, okay, means the performance. The most of the operations take less than 30 seconds in case of the standards queue. I told you, if an application server goes down, it will identify less than 30 seconds in case of standards queue. But in case of basics queue, it will take at least 1 to 2 minutes to identify. Again, after some time, if the application server comes back online, within less than 30 seconds, the standards queue will identify that is healthy, but the basic will take some time, around 60 to 90 seconds of time to identify. And the last one about the charges. Both the load balancers are free only. There is no charges for the load balancer. But the charges happening based on the number of data that processed. The egress and ingress happens in the load balancer. The charges are applicable for the standards queue, but for the basic queue is completely free. Okay, so that's why when you are planning for a solution, you have to ensure you should understand what is the relevance of each and every resources. what is the importance of the resources. You should know all these basic things. If you simply go to the load balancer and create one basic load balancer and then try to add application servers from two different region, it won't support. So for that you have spent some time, 2-3 hours of time you might have spent, correct na? So that is go wasted. So that is why ensure before you do anything, start questioning yourself. Okay, so now you got all the differences. Okay, so if you see the differences, you always feel standard SKU is better because that supports multiple regions, multiple availability zones. The performance is very good, and the backend connections resets automatically, and there is no charges, only for the egress and ingress charges are there. Okay, so these are the difference between the basic and standard SKU of the load balancer. Okay, and if somebody asks you what is SKU, see here, the SKU is nothing but the stack keeping unit. Okay, SKU is nothing but the tariff, I could say. So you might have heard the tariff. If you recharge 199 rupees per day, 1 GB free, 30 days. If you recharge for 999 per day, 2 GB internet free, and the validity is there for 6 months. So that is the SKU, the tariff. Though SKU is nothing but stack keeping unit, means what kind of tariff you wanted to have. You want to go with the basic tariff or the standard tariff. Correct? Na? The same thing. SKU is nothing but stock keeping unit. Fine. Now, how to build the load balancer? See, this is a solution. Imagine you are trying to access an application called www.facebook.com, and I should be able to access the application public facing. See, you should build a public load balancer. First of all, you should build a standard public load balancer, and you should build 3 virtual machines or at least 2 virtual machines behind the load balancer. In this scenario, I am giving 3 virtual machines, but in the lab we will do only 2 virtual machines. Okay, so what we will do, we will build a standard load balancer, and we will build 2 virtual machines, VM01 and VM02. Okay, and try to deploy the application. We will deploy one HTTP website we will create, and try to access the application via public load balancer, and we will see how the connectivity goes. If I browse, it will go to the VM1. If you browse, it will go to the VM2, and for some time we will shut down VM1 or VM2 and see the connection should always go for one applications, whether you are accessing, me accessing, someone else is also accessing, because there is no multiple VMs, because there were only 2 VMs, out of 2 one has got unhealthy, so only one is healthy, so application should always go to that particular application server. The steps to build the load balancer: go to the network services or go to the global search and browse, search the load balancer. So you will get the load balancer option. Then you click on create a new load balancer, select the subscription, select the resource group, select the region, and what kind of load balancer you wanted. Then create the load balancer, and then you create the backend pool, add the backend pool, create the help prop, and create the load balancer rule, and that's it. Then get into the virtual machine, install the IIS, configure some website in both the virtual machine. Once you are done with the configuration, then start browsing the public load IP of the load balancer. Then you will see the application access. Okay, the same thing I am going to do it in the lab. Okay, so let me stop the theory portion here, and we can get started with the lab. Thanks all.